We've talked about that fact that sometimes the order that things are selected doesn't matter. You're just concerned whether things are selected but not in any certain order. That's when we have a combination. For example, when addressing an envelope, it's important to write the 6-character postal code in the correct order. However, putting the address on, putting the stamp on, and putting the contents in the envelope can be done in any order. So we're going to learn about counting outcomes when order does not matter. And this is a combination. Remember permutations, we've been spending time talking about those. That's where order matters. And we found that we can use the fundamental counting principle to do permutations, or we can use factorials or NPR. But a combination is a selection of a group of objects taken from a larger group for which the kinds of objects is important, but not the order in which they are selected. There are several ways to find the number of possible combinations. One is use reasoning. Use the fundamental counting principle and divide by the number of ways that the objects can be arranged amongst themselves. So that would be one way to do it. For example, to calculate the number of combinations of 3 digits made from the digits 1, 2, 3, 4, and 5 without repetition, there would be 5 choices for the first, and 4 for the second, and 3 for the third, which gives us 60 ways to arrange 3 items from 5. However, the 3 digits can be arranged in 3 factorial ways amongst themselves, so we divide by 3 factorial. That would be one way to do it. So this would allow you to still use the fundamental counting principle, and that would give you 10 different combinations. Or we can use the notation NCR, which can be written sometimes with these brackets with N on top, R on the bottom. And the formula for NCR is NPR over R factorial, which is what we just talked about, using the fundamental counting principle and then dividing by how many ways those objects can be arranged amongst themselves. And NPR is N factorial over N minus R factorial, which is then divided by R factorial, or this expression right there. And that's the one that's on the formula sheet. There are always fewer combinations than there are permutations. Because with permutations, you're calculating how many ways it can be arranged amongst themselves. They are selected and then arranged amongst themselves. But with combinations, they're only selected. So there's always more permutations than there are combinations because the formula involves an extra factor on the bottom of R factorial. It makes your denominator larger, which is going to give you a smaller number in the end. So a combination is a selection of objects without regard to order. All of the 3-letter combinations of P, Q, R, and S are given there. There's only 4 3-letter combinations. So in this case here, you are selecting 3 from 4, so that would be 4C3. Using the formula, it'd be 4 factorial over 4 minus 3, which is 1 factorial. But then you're also multiplying by R factorial. So there are 4, because 4 factorial divided by 3 factorial will just give you 4. And these are the 4 different combinations. However, if you want to know how many different permutations there were of the letters P, Q, R, and S, if only 3 are selected, that would be 4P3. It would be 4 factorial over 4 minus 3, or 1 factorial. That's 24. Again, there's always way more permutations than there are combinations. Okay, or instead of using the formula, again, you can use a calculator to calculate 4C3. So you're going to go 4, you're going to go math over to probability, and number 3 in the list is NCR. So 4C3, again, gives you your answer that way. One example of a combination is Lotto 649, or any lotto for that matter. You are just selecting numbers. The order they're selected doesn't matter. In the end, you want to match the numbers you selected with the ones that were drawn. So for a person to correctly choose 6 numbers from 1 to 49, it would be 49 C6. 6 are being selected from 49. The order that they are chosen doesn't matter. So if we use our calculator to find out what 49C6 is, 49C6 is a pretty big number. It's 13,983,816. So that means that if you were to buy one ticket with every possible combination of numbers, that's how many tickets you'd have to buy. Sometimes the lotto gets up over 20 million, 30 million, 50 million. Lotto Max, you have to choose 7, so there's more combinations, but Lotto 649 has gotten up over this amount. So you might be wondering, well, why wouldn't you just buy, if you had the money, why wouldn't you just buy one ticket for every possible combination? You'd be guaranteed to win. However, what if someone else also picks those numbers? Now you got to split the pot. What if 2 other people? Now you're splitting it 3 ways. So unless you're guaranteed that you're the only person that wins, you very well could be losing money on this. And I guess if you have that much money sitting around, you could afford to lose a few $1,000,000. But some of you, I'm sure, are destined to be multimillionaires, so you can find that out for yourself someday. Okay, Rihanna is writing a geography exam. The instructions say that she must answer a specified number of questions from each selection. How many different selections of questions are possible if she must answer 2 of the first 4 questions in part A and 3 of the 5 questions in part B? So once again, the order she selects these questions doesn't matter. She just has to choose 2 of the 4 from part A. So that would be for C2, and remember, and means times. Then she has to choose 3 from 5. So that'll be 5C3. So you can actually do this all at once in your calculator, or you can do each one individually. Doesn't matter. 4C2 is 6 times 5C3, which is 10. And when you multiply those, you're going to get 60. And like I said, you can put this whole thing in at once if you want. There's 4C2. You just have to move the arrow to move it over from the 2 where it's written as a subscript, and then it's 5C3. Whoops, try that again. So 4C2 times 5C3. So you can do it all at once to get your answer. Right? Calculator will do that. And this question, like part A, that's a very common type of question to see in a diploma exam. Usually in a multiple choice or numerical response question. What if she must answer 2 of the 4 questions in part A and at least 4 of the 5 questions in part B? So that means it can be 2 from A and either 4 from B or 5 from B. At least 4 means 4 or more. So we're actually going to have to do 2 different scenarios here and then add them together. That'll be the or part. So the first scenario is 2 from A, so that was 4C2, and 4 from B, 5C4, or, which means add, 4C2, again the 2 from part A, and all 5 from part B. So that'd be 5C5. So I can just edit the last one I did, 4C2 times 5C4 is 30. Or means plus. I can edit the last one and just change that 4 to a 5. 4C2 times 5C5 is only 6. See, 5C5 is 1. You're selecting all 5 from 5. The order doesn't matter. 5C5 is 1. 4C4 is 1. 3C3 is 1. You're selecting all of them, and order doesn't matter. There's only one way that can happen. So 4C2 is 6, because this last part will be 6 times 1. But anyways, when you add the 30 and the 6 together, you'll get a total of 36, and there's your answer. Right? On the next page, there are 12 females and 8 males in a grade 12 class. So obviously it's an awesome class. Obviously. Principal wishes to meet with a group of 5 students to discuss graduation. How many selections are possible? So again, the order doesn't matter. They're just being selected. Therefore, it's a combination. And in this case, there's no separating females and males. So if he just wants to meet 5 students from all of them, it would be 30C5. There's no restrictions on how many males and how many females can be selected. That comes into Part B. But for Part A, there's no restriction. It's just 30C5. And we get 142,506 combinations. But then Part B says how many selections are possible if it must consist of 2 females and 3 males. So here we've got our restrictions. And again, this is a common type of questions you see on diploma exam, something like this. So the 2 females have to be chosen from the 12 females that are in the class. And times the 3 males are selected from the 18 males that are in the grade 12 class. So again, we can put this entire expression in our calculator all in one step. There's our 12C2, and that's multiplied by 18C3. Which gives us 53,856. So because we have those restrictions there are fewer combinations. Okay? Again, that's a very common type of question you see on the diploma exam. Question C, one of the female students is named Brooklyn. And she's obviously very needy. How many 5-member selections consisting of Brooklyn, 1 other female, and 3 males are possible? So Brooklyn's already on the committee. There's only one way that can happen. So that's what that 1 represents. They need 1 other female. We started with 12 females. Brooklyn's already on the committee, so now there's only 11 left to choose the 1. So that'll be 11C1. And then the other 3 are the males, and they come from the 18 males that are in the class. So it's going to be 1 times 11C1, we're going to see is 11. 11C1 is 11. There are 11 other females. You're going to choose 1. Well, there's 11 ways that you can do that. And then that's multiplied by our 18C3. And 18C3 is 816. So that's going to be multiplied by 11. 8976. The more restrictions you have, the fewer combinations are going to be possible. Jackson, the principal's son, is in the class and has to be in the group. How many 5-member groups include Jackson? So this is the only restriction, that Jackson must be in the group. There's only one way that can occur, and then the other 4 have to come from the remaining 29 students, which would be 29C4. So essentially it's just 29C4 $23,751. Twins Peter and Sarah are in the class but cannot both be in the group. How many? That should be 5-member groups. Do not include both twins. So there's a couple different ways that this can be done. Here's one way to do it. So we'll call this solution 1. And that would be to take all combinations minus the combinations with both twins. Like we did a question similar to this in last class. Because there's only really a couple of things that can happen here. Either one or the other is in there, either they're both in there, or none of them are in there. And the only one that can't happen here is that they both can't be in there. So all the other possibilities could be found by taking all combinations minus the combinations with both twins. So all the combinations, we calculated that way up in part A. 142,506. That's 30C5. Minus the combinations with both twins. So again, that's the only restriction. If you have both twins, there's only one way that can occur, but that takes 2 of the 5 spots. So the other 3 spots have to come from the remaining 28. It's a class of 30 to begin with. And the other 3 have to come from the remaining 28. So our 30C5, and then we have to subtract 28C3. Gives us 139,230. And as I said, there is another way that this can be done. So we'll call this solution number 2. So again, they both cannot be in the group. So that means Peter in, Sarah out is one possibility. Or Sarah in, Peter out is another possibility. Or both out. These are the only things that can happen in this case because they both cannot be in the group. So, Peter in, Sarah out. So if Peter's in, that's the first position. There are 29 students left to choose the remaining 4. However, Sarah can't be one of those. So now there's only 28 students left to choose the remaining 4. So that would be 28C4. Sarah in, Peter out will be the same thing, 28C4. If Sarah's in, there's one of the 30. There's 29 left, but it can't be Peter. So now we're down to 28 to choose the remaining 4. And we could say it's 1 times, and that 1 represents Peter in and then Sarah in. Only one way that can happen. And if they're both out, that means you're selecting 5 from the other 28 students. And because these are ORs, you will add all these up. So let's do that. And we'll see we're going to get the same answer. 28C4 And we can just multiply that by 2 if we want, because we have 2 of those that we're adding together. But my order of operations is going to mess this up, so I'm going to have to do it the proper way. Put another 28C4 there. And then I'll add 28C5. So we put that in there and we get exactly the same answer. 139, 230. Right, same answer, so they both work. The last one on this page says there must be at most 2 girls in the 5-member group. So that means there could be 5 boys and 0 girls, or 4 boys and 1 girl, or 3 boys and 2 girls. At most 2 girls means you can't have more than 2. So we've got 3 different scenarios here that we will have to add together. And remember, the word and means to multiply. The or is the part that's going to add. So 5 boys means you're only selecting 5 from the 18 boys. Plus 4 boys would be 18C4 times 12C1 for the 1 girl from the 12. Or plus 3 boys would be 18C3 and times the 2 girls, which come from the 12 girls that are there to choose from. So you could do this all in one calculation, but let's do each individual part first. (18C5) is 8568 plus, I'm going to store that into memory slot A, now I'll do 18C4 times 12C1 which is 36,720. I'll store that into memory slot B. And the last one, 18C3 times 12C2 53,856. And now we'll add those 3 together. So that number plus the number in memory slot A and the number in memory slot B. 99,144 is our answer. Okay. For practice, you should work on these questions.